Hey guys, this is Einar. I hope you're doing great today, and welcome to this tutorial where we're going to learn about how to look up probabilities using critical set values in a normal distribution. And we're going to be using tables that look like this for that. So to begin with, what are we looking for? Well, say that I have a critical z value somewhere along this axis over here, and I want to know how many percent of the distribution is located to the left of this critical point. So say I'm looking for -1 here. Then I might want to know how many percent, or what the probability is of getting a value that is lower than my critical z value, and vice versa for the plus side, of course. We're also going to be looking at how we can find the probabilities in between critical z values. Now we can do this because the normal distribution is a symmetrical distribution. So if I have a critical z value of -2 and a critical positive z value of 2, I'm going to have the same amount of percent in each of these tails, which also means that I can use these values to calculate how much I have in the middle. And I think we're just going to get right to it and start calculating. So say I want to know the critical z value for when I have 0.5% in my left tail of the normal distribution. So we're going to be way out here somewhere. I just want 0.5% in my tail over there. What I do is I look in these tables, and in this table we have our z values, which is what we're looking for, and we have the percent to the left of our critical z values, which is indicated here by the shaded area. So as I said, we were looking for 0.5% to the left of our critical z value. Okay, so let's take a look. What we're looking for is 0.5 in this percent to the left column. So I go down here and I see somewhere around 0.49 and 0.51. I could choose any one of these. It really doesn't matter that much. But I'm going to choose -2.58 is my critical z value. See here, the z values. I go down here. -2.58 is located right next to 0.49% to the left. So along our axis here, I'm just going to remember this, -2.58. Okay, so what we're doing is we're going along this x-axis here, 2.58 right here, somewhere around here, and we're saying 0.5% of the distribution is located to the left of that. So I write that in here, -2.58. Let's do this for if we want 2.5% to the left of our critical z value. So what I do is go look at my table again. This time we're looking for 2.5%, so I look in my columns. These are the z values, the percent, so I think we're moving up here somewhere. And there we got it, 2.5%. I get a critical z value of -1.96. So I go up to my table here and I enter that value, -1.96. So at the critical z value here along the axis of 1.96, this point somewhere here, we can say that we have 2.5% here to the left in our tail. And for 5% then, same procedure. I'm looking here. 5%, well that should be somewhere around in between these. I'm going to choose -1.64 in this case. So I go back to it and just write -1.64. And that's fair enough, but say I want to know the percent between two z values. So I want 99% of my distribution to be located in between two z values. How do I go about doing this? Well, if I have 99% in between my two z values, that also means that I have 0.5% in each tail. Let's consider this. I want 99% in the middle. The total distribution is 100%. So that should leave 100 minus 99% left in tails. And because I have two tails, I just take this number and divide it by 2. And I get 0.5%. So I'm looking for the critical z value where I have 0.5% in each tail. Now, of course, I could go down to my tables and look it up here, and I get -2.58 here. We already calculated it there. So this is actually what we're looking for. So I'm just going to write 2.58 there, no minus, because what we're implying here is that because the distribution is symmetrical, we're talking about the percent between +2.58, which is going to be somewhere around here. So I have +2.58 here and 0.5% in the tail on the positive side. And for the negative value, I go the other direction. So I have 2.58 here and I have 0.5% in my left tail in the negative side, and then I will have 99% in between. Don't mind the shades, they're just to show you what we're looking for. This is not exactly, doesn't illustrate what we're looking for in this, in this specific example. So 2.58 would actually be located here, and the colors would go out a bit further than there are on this picture, and we would have 0.5% there and 0.5% there. So in this way you can actually use one-sided tables, which can be found in many statistics books, to find intervals between critical Z values. And there are tables that actually look up percents, where the percents represent the area between the Z values. So be careful about that when you're looking up Z values with tables. Take a look at the picture and see that what you're actually finding here in the percent column. I think I'll do one more, and then you can solve the last one here for 5% by your own, or for 90% in this case. Say we want 95% between our Z values. Okay, that means that we have 5% outside our shaded area here, and if you divide that by 2, we're going to get 2.5, and I'm going to show you that. So we have 95 here, 100 is our entire distribution, which leaves 5% outside the shaded area, and because we're talking about a two-sided distribution here, we're going to divide this by 2, and we get 2.5 in each tail. That's what we're looking for. Okay, 2.5, actually we've already have it here. We'll check that. So I can just write 1.96 there, implying of course that this is plus and minus. So 1.96, we move along, 1.96 somewhere here. We have 2.5% on the positive side, and minus 1.96 around there. We have 2.96% to our left. So that's how you use tables like this to find probabilities using critical Z values. Have some fun playing around with this. Check out different probabilities and their characteristics, and I hope you have a really great day. Bye bye.